Dear students, today we shall discuss about circular motion. Circular motion. So, what is the meaning of circular motion? So, before going to circular motion, let us first discuss what is a circle. When a body moves on the circle, the motion of the body is called circular motion. What is a circle? Circle is a locus of a point which moves so that its distance from a fixed point always remains constant. That is the definition of a circle. Circle is a locus of a point so that moves in such a way that its distance from a fixed point always remains constant. The fixed point is called center of the circle and the fixed distance is called radius of the circle. So, when the body moves over a circular path, the motion is called circular motion. Now, what is the axis of that circular motion? It is a straight line passing the center and perpendicular to the plane of the circle, that is the axis. What is the meaning of time period? What is the meaning of time period? Time period. Body is moving on a circular path. What is time period? It is defined as the time taken by the body to make a complete revolution. Time taken by the body to make a complete revolution is called time period. Time taken to make a complete revolution. Time taken to make a complete revolution is called time period. Then what is frequency? Frequency. What is the meaning of frequency? It is the number of complete revolutions made per second. It is defined as the number of complete revolutions made per second. Frequency. गोटे सर्कुलर मोशन गोटे पाथ रिवोल्यूशन करने जी समय नाला टाइम पीरियड गोटे सेकेंड जिते थर घूरला से फ्रिक्वेंसी. व्हाट इज द रिलेशनशिप बिटवीन टाइम पीरियड एंड फ्रिक्वेंसी? रिलेशन बिटवीन टाइम पीरियड capital T and frequency small n. What is the relationship between them? Relation between time period and frequency. Time period is the number of oscillations by revolutions made per second. Frequency is the number of revolutions made per second. So, what will the T will be equal to what? 1 by n. T will be equal to time in 1 second n revolutions are made. So, for one revolution, what is the time? 1 by n. So, n into t is equal to what? 1. Frequency into time period, frequency into time period is product of frequency and time period is equal to 1. So, the basic thing which will be required in our circular motion. So, in circular motion, we will come across angular displacement, angular velocity, angular acceleration. In normal kinematics or motion in a straight line, we come across linear distance covered, linear velocity, linear acceleration. Since a circular motion, but when a body moves over a circular path, it moves distance, at the same time it covers angle. So, there will be angular velocity and there will be there will be angular acceleration, angular displacement, etc. So, let us define the things. What is the meaning of angular displacement? Angular displacement, angular displacement, angle covered by the body, symbol is usually taken as delta theta, angular displacement. So, the body is moving like this, body is moving on a circular path, radius is r, OA, A to B, the angle covered is equal to what? Delta theta, distance covered is equal to what? Delta s. So, this is when the body is moving over a circular path, in addition to the distance covered, it covers angle. So, delta theta angle covered is what is angular displacement? Angular displacement delta theta. What is linear displacement? Linear displacement delta s. And what is the radius of the circular path? R is the radius of the circular path. Radius of the circular path, radius of the circular path is equal to R. Angular displacement is equal to delta theta. Linear displacement is equal to delta s. What is the relationship between them? Delta theta, delta s and r. As you know from geometry, delta theta is equal to what? Delta s by r. Delta theta is equal to delta s by r, or delta s is equal to r delta theta. Delta s is r delta theta. So, linear displacement is equal to radius into angular displacement, Linear displacement is radius into angular displacement. Then in which unit will you measure linear displacement? You measure in centimeter, meter, etc. Then how do you measure angular displacement? Unit of angular displacement. Unit of angular displacement. What is the unit of angular displacement? How do you measure angular displacement? We measure the angle either in degree or in radian. Normally we measure it in radian. In degree, you know that pi radian is equal to 180 degree. So, pi radian, that you remember this, pi radian is equal to 180 degree. It is made in radian. It is a scalar vector quantity. Angular displacement is a vector quantity. Angular displacement, remember it, angular displacement is a vector quantity. Then how it is represented by vector? Vectorical representation like this: delta s is equal to delta theta cross r. Delta s is delta theta cross r. Linear displacement is given a cross product of angular displacement and radius, delta theta cross r, cross product. So, angular displacement vector quantity, it is given delta s is delta theta cross r. So, this is about your angular displacement. Then what about angular velocity? Angular velocity it is normally denoted by omega. Angular velocity normally denoted by omega. What does it mean by angular velocity? Defined as the angle covered per second. In 1 second, what is the angle covered? So, angular velocity omega is equal to what? Delta theta by delta t, angular velocity. Angular velocity is equal to delta theta by delta t. What is delta theta? delta theta is angular displacement, delta t is the time taken. Delta theta angular displacement, delta t time taken. So, how to write instantaneous angular velocity? Instantaneous angular velocity, instantaneous angular velocity will be instant, the time will be very very small. So, limit delta t tending to 0, delta theta by delta t, which is equal to your rate of change of angle d theta by dt. Instantaneous angular velocity. Instant means very small time. So, when time becomes very very small, the angular velocity is called instantaneous angular velocity. The limit delta tending to 0, delta theta by delta t, d theta by dt. Then what will be its unit of angular velocity? Its unit theta by its unit will be what? Radian per second, radian per second. Unit is radian per second. What is the dimension? Dimension of angular velocity, dimension of angular velocity. How to write the dimension of angular velocity? Radian has no dimension. So, this is simply 1 by t or t to the power minus 1 dimension of angular velocity, because angle has no dimension. Since angle has no dimension, angle has no dimension, angle has no dimension. So, this dimension is t to the power minus 1 radian per second, unit is radian per second and dimension is t to the power minus 1 angular velocity. Whether it is scalar or vector quantity, angular velocity is a vector quantity. Angular velocity is a vector quantity. Angular velocity is a vector quantity. How do you denote it? Your angular velocity, how to denote it? Linear velocity v is equal to omega cross r. V is equal to linear velocity is omega cross r. V is equal to omega cross r. V omega cross r. Angular velocity vector quantity v. Linear velocity is angular velocity at the cross product of angular velocity and the radius of the circular path. Then comes angular acceleration. Angular acceleration. Angular acceleration. Angular acceleration. Symbol is alpha. Angular displacement theta, angular velocity omega, angular acceleration alpha. It is defined as the rate of change of angular velocity, rate of change of angular velocity, defined as the rate of change of how, with what rate the angular velocity is changing. So, alpha is equal to what? D omega by dt, rate of change of angular velocity. Alpha is rate of change of angular velocity, that is d omega by dt. Then what will be unit? Instant, how to write instantaneous angular velocity? It will limit delta t to 0, delta omega by delta t. Instantaneous angular acceleration. Instantaneous angular acceleration will be limit delta t tending to 0 delta omega by delta t, or that is your d omega by dt. Instantaneous angular acceleration limit delta tending to 0 delta omega by delta t, d omega by dt. What will its unit? Its unit is angular velocity by time. Unit of angular velocity is radian by second. Further again divide by time. So, radian per second square, radian per second square. Unit is radian per second square. Its dimension is t to the power minus 2, because radian is not known dimension, second square t to the power minus 2. It is also a vector quantity, radian. So, angular displacement, angular velocity, angular acceleration, these things will be used in uniform circular motion, will use these things. Now, we shall discuss about equations in circular motion. What will be equations of motion? Equations of, you know the equations of linear motion. So, let us discuss the equations of rotational motion here. As you know, equations of linear motion, you know the equations of linear motion. This equation V is equal to u plus a t, S is equal to u t plus half a t square, V square is equal to u square plus 2a s, s nth, distance covered in a second is equal to u plus 2n minus 1 by 2 into a. These equations are equations of linear motion, where u is initial velocity, v is final velocity, a is uniform acceleration, a is distance covered, s nth is distance covered in a second. U is initial velocity, v is final velocity, a is uniform acceleration, s is distance covered, s is the distance covered, s nth is distance covered in nth second, So, these are the equations which you are using in linear motion. These equations will be taught to you in kinematics. Similarly, in case of circular motion, we will use equations, that the corresponding equations in angular motion. What are the equations? Similar equations in angular motion, equations in angular motion, rotational motion, equations in rotational motion, similar equations, rotational motion, equations in rotational motion, similar equations will be there, equations in rotational motion. What are the equations? Equations will be, first equation will be omega will be omega 0 plus alpha t, omega will be omega 0 plus alpha t, omega 0 plus alpha t is first equation. Second equation, here it is a linear distance, s is equal to u t plus half a t square. In angular motion, in case of instead of linear distance, we will take angle covered. So, what will the equations? Equation will be theta is equal to, in place of s there will be theta, here it will be omega 0 t plus half alpha t square, this equation alpha t square, t will remain as such, there will be no change in t. So, this equation will be omega 0 t plus half alpha t square. Third equation, v square, here omega square will be equal to u square omega 0 square plus 2 alpha into theta, 2 alpha theta. In place of a there will be alpha, in place of s there will be theta. So, omega square is omega square plus 2 alpha theta, and the last equation, here it is distance covered in ns second, here it is angle covered in ns second, theta nth, angle covered in nth second, angle covered in nth second, that will be equal to what? Omega 0 in place of u, it will be omega 0 plus 2n minus 1 by 2 into alpha. So, these are the 4 equations which will involve in rotational motion or angular motion. Corresponding equation v is equal to u plus a t, corresponding to omega is omega 0 plus alpha t, s is equal to t plus half a t square, theta is omega 0 t plus half alpha t square. Here v square is u square plus 2s, omega square is omega 0 square plus 2 alpha theta, theta nth angle covered in n second, omega 0 plus 2n minus 1 by 2 into alpha, like this. These equations can also be proved by calculus method, which are not that important so far as your circular motion is concerned. So, just we will apply these equations in case of numericals, where it will be necessary. Omega is equal to omega 0 plus alpha t, theta is equal to omega 0 t plus alpha t square, like this, these equations will be used. Proof of the equations by calculus method, proof of the equations by calculus method. This calculus method will be important for you, because in the examination if it is asked, you have to prove it by calculus method. The first equation will prove omega is equal to what? Omega 0 plus alpha t. We will prove this equation by calculus method. How to do it? Uniform angular acceleration, symbol is what? Alpha, that is equal to what? d omega by dt, rate of change of angular velocity d omega by dt, rate of change of angular velocity, So, what is d omega? Alpha into dt. D omega, what is d omega? Change in angular velocity. What is the time? Time is dt. But in this case, now we will find out the equation. Initial angular velocity is omega 0, final angular velocity is omega. So, how to do that? Integrate it, integrate d omega. What are the limits? Omega 0 to omega. Integrate this side, alpha dt, time 0 to t. When time is t is equal to 0, angular velocity omega 0. When time t is equal to t, angular velocity omega. So, this will be integration will omega from omega 0 to omega. Here alpha dt integration is t from 0 to t. That you will know in the mathematics when you will read calculus, integration in calculus, you can know it. So, this becomes how much? Omega minus omega 0 is equal to alpha t minus 0. So, omega 0 is equal to omega 0 plus alpha t. This is how we prove it by calculus method. Omega is omega 0 plus alpha t, this equation. Similarly, second equation also can be proved by calculus method. Second equation, theta is equal to what? Omega 0 t plus half alpha t square. In this case, what is this? Omega 0 is initial angular velocity, alpha is uniform angular acceleration, and theta is angle covered. Omega 0 initial angular velocity, initial angular velocity alpha uniform angular acceleration, uniform angular acceleration, theta angle covered, these are the things, angle covered, t time taken. So, how to prove this equation? Theta is equal to omega 0 t plus half alpha t square. You know this, omega is equal to what? D theta by dt. That is, angular velocity is equal to rate of change of angular displacement. Angular velocity rate of change of angular displacement, angular velocity rate of change of angular displacement. So, omega angular velocity rate of change of angular displacement. So, what is d theta? Omega into dt. We already know that omega is equal to omega 0 plus alpha t. Put it here, omega 0 plus alpha t dt. So, d theta is equal to how much? D theta is equal to omega 0 into dt plus alpha t dt. So, during time dt, angle covered is d theta. We will find out angle covered in time theta, time t, that is angle covered is theta. Then what is the expression for that? Integrate it, d theta integration from 0 to theta, integration omega 0 dt from 0 to t, time alpha t dt from 0 to t. Because when time is 0, angular displacement is 0. When time is t, angular displacement is theta. That you can remember. When time is equal to 0, angular displacement is 0. When time is equal to t, angular displacement is equal to theta. Time is equal to 0, angular displacement is 0. When time is equal to t, angular displacement is theta. That we put here, 0 to theta d theta, 0 to t omega 0 dt plus alpha t dt integration from 0 to t. So, now let us integrate the integration of d theta, e theta from limits 0 to theta. Omega 0 is a constant, initial angular velocity, integration of dt is t from 0 to t, plus alpha is constant, integration of t dt t square by 2 from 0 to t. So, this becomes what? Theta minus 0 is equal to omega 0 t minus 0 plus alpha by 2 t square minus 0 square. Clear? So, this becomes what? Theta is equal to omega 0 t plus half alpha t square. Second equation reduced by calculus method. Theta is equal to omega 0 t plus half alpha t square. Now, we will go to third equation. We will prove it by calculus method. Third equation. The third equation is omega square is equal to omega 0 square plus 2 alpha theta, which is similar to the equation in linear motion, that is v square u square plus 2s. যেমতি linear motion equation আছে v square is equal to u square plus 2s, same the angular motion equation is omega square plus omega 0 square plus 2 alpha theta. how to prove this equation by calculus method. Let us prove it by calculus method. So, let us take it like this. Alpha is equal to, start from this, d omega by dt. Alpha is equal to d omega by dt. That is angular uniform angular acceleration is equal to rate of change of angular velocity. Alpha is d omega by dt, or d omega is equal to how much? Alpha into dt. Alpha into dt. Let us multiply both the sides by omega. So, omega into d omega is equal to alpha into omega into dt. Multiplying both the sides, multiplying both the sides by omega, multiplying both the sides by omega. So, this becomes what? Omega d omega is equal to alpha. In place of omega you can write omega 0 plus alpha t dt, because omega is equal to omega 0 plus alpha t. So, omega d omega is equal to alpha omega 0 dt plus alpha square t dt. So, when your time is 0, your omega is omega 0. When time is t, angular velocity is omega. Now, integrating with that limit, what are the limits? Omega 0 to omega, omega d omega, 0 to t, omega 0 dt, plus 0 to t, alpha square t dt. Because why do we write it like this? When time is 0, angular velocity is omega 0. When time is t, angular velocity is omega. That inside the bracket you can write. When time is zero, angular velocity is omega 0. When time is t, angular velocity is equal to omega, angular velocity omega. So, let us integrate it with this limit. So, this becomes what? Integration of omega d omega is omega square by 2. We are using this formula, integration of x to the power n dx is equal to x to the power n plus 1 by n plus 1 plus a constant of integration c in all cases except when n is equal to minus 1. This formula is used everywhere. X to n dx integration is x to n plus 1 by n plus 1 plus f c except when n is equal to minus 1. The c is a constant of integration. This is a constant of integration. Constant of integration. In this case, we are not taking constant of integration because the integration is made with a definite limit. When the integration is not made with a definite limit, there will be constant of integration, but when the integration will be made with a definite limit, there will be no constant of integration. So, that formula will be used here, that is your omega square by 2 from omega 0 to omega. Alpha is a constant, omega 0 is a constant. So, alpha omega 0 has nothing to do with the time. Integration of dt is t from 0 to t plus alpha square constant t dt, t square by 2 from 0 to t. So, this becomes what? Now, put the omega square minus omega 0 square by 2, upper limit minus lower limit, omega square minus omega 0 square by 2 is equal to alpha omega 0 t minus 0 plus alpha square by 2 t square minus 0 square. So, this becomes what? Omega square minus omega 0 square by 2 is equal to alpha omega 0 t plus half alpha square t square. That is equal to, from this we can take alpha common, that is equal to alpha taken common omega 0 t plus half alpha t square. But we know that omega 0 t plus half alpha t square is what? That is your theta, that is alpha theta angle covered. So, omega square minus omega 0 square is equal to 2 alpha theta, or omega square is equal to omega 0 square plus 2 alpha theta. So, this is the equation. Third equation, omega square is omega 0 square plus 2 alpha theta. Now, let us come to fourth equation, the last equation of angular motion, that is the angle covered in ns second. Angle covered in ns second, that is the angle covered in a particular second. Angle covered, fourth equation, theta nth is equal to omega 0 plus 2n minus 1 by 2 into alpha. That is your angle covered in nth second. Angle covered in nth second. In nth second. Angle covered in nth second. Similar equation is there in linear motion. Distance covered in nth second, 10 second, 11 second, 6 second, like that. So, how to find out? That to know that omega is equal to what? D theta by dt. Angular velocity, rate of change of angular displacement. So, d theta omega dt. In place of omega, you can write omega 0 plus alpha t dt. D theta is omega 0 plus alpha t dt. That is equal to what? Omega 0 into dt plus alpha t dt d theta. This is the angle covered during time dt. Our aim is to find out angle covered in a particular second, that is theta nth, angle covered in nth second, that we will find out. Here, when t is equal to what? T is equal to n minus 1, theta is equal to what? Theta n minus 1. Angle covered, distance angle covered in n minus 1 second, that is angle covered in n minus 1 seconds. When t is equal to n, theta is equal to theta n, that is your angle covered in n seconds. T is equal to n, that theta angle covered in n. So, what is theta nth? Theta nth is equal to what? Theta n minus theta n minus 1. So, theta nth is equal to what? Theta n minus theta n minus 1, that is your angle covered in nth second, particular second nth. Theta n minus theta n minus 1, the angle covered in nth second. So, now we will integrate it to what? Integration will be made from what? Theta n minus 1 to theta n. D theta will be integrated from theta n minus 1 to theta n. Omega 0 dt. Time will be integrated from what? N minus 1 to n plus alpha t dt. Time will be integrated from what? N minus 1 to n. So, we will find out distance covered in n minus 1 seconds, angle covered in n minus 1 seconds. So, this becomes d theta. left hand side integration theta limit theta n minus 1 to theta n. Right, come to right hand side, omega 0 is a constant, dt integration t n minus 1 to n plus alpha integration of dt dt t square by 2 from n minus 1 to n. So, if you solve it, you will find out angle covered in n second. So, this becomes what? Upper limit minus lower limit theta n minus 1, which will be theta nth, omega 0 upper limit n minus 1 plus alpha by 2 upper limit t square n square minus n minus 1 whole square. So, this becomes what? Theta n minus theta n, angle covered in n seconds minus angle covered in n minus 1 seconds is angle covered in nth second, that is your nth second, theta nth. Suppose you are asked angle covered in 10th second, angle covered in 10 seconds minus angle covered in 9 seconds, that is angle covered in 10th second. Similarly, in general, angle covered in n second is angle covered in n seconds minus angle covered in n minus 1 second, that is equal to what? Omega 0 n minus n plus 1 plus alpha by 2 n square a minus b whole square a square plus b square minus 2ab minus n square minus 1 plus 2n. So, this becomes what? So, theta nth is equal to what? Omega 0 plus n square cancels plus 2n minus 1 by 2 into alpha. So, this is the expression for angle covered in n second. Similarly, distance covered in n second is equal to what? U plus 2n minus 1 by 2 into a, where a is uniform linear acceleration, your alpha is uniform angular acceleration. So, with these ideas of angular motion, now we will go to uniform circular motion. Uniform circular motion and the concept of centripetal force, etc. Uniform circular motion. Uniform circular motion and the concept of centripetal force, centrifugal force, etc. What is the meaning of uniform circular motion? When we say that motion is uniform, if the body covers the circular path in a fixed time, same time, the motion of the body is said to be uniform circular motion. So, motion of the body is said to be uniform circular motion when it takes equal time for each revolution. If the body takes equal time for each revolution, then motion is said to be uniform circular motion. To suppose motion of earth round the sun, it takes always the same time 365 days. Motion of so, if the body is taking equal time for each revolution, the motion is said to be uniform circular motion. Suppose radius of the circular path, for example, say the radius of the circular path is r and speed is equal to, say, for example, v, with speed v it is moving. So, radius of the circular path is equal to r, uniform speed is equal to v. Suppose the uniform speed is v, radius of the circular path here. In one revolution, what is the distance covered? In one revolution, distance covered is equal to how much? 2 pi r. In one revolution, distance covered is 2 pi r. So, speed is equal to linear speed. So, linear speed is equal to what? 2 pi r by t, where t is time period, where t is time period, t is time period, t is time period, t is time period, 2 pi r by t. What is the angle covered? Angle covered is equal to 2 pi. So, angular velocity, what is the angular velocity? Angular velocity of omega, that is 2 pi by t. So, your linear speed 2 pi r by t, angular velocity omega 2 pi by t. So, V is equal to what? Omega r. V is equal to omega r. Linear speed is equal to angular velocity into radius of the circular path. Now, in uniform circular action, use the concept of centripetal force, idea of centripetal force. Concept of centripetal force, centripetal force or center seeking force. Centripetal force is also called center seeking force. What is the meaning of center seeking force? When a body moves on a circular path, what happens? Its speed remains constant, but velocity changes from point to point, because direction of velocity is along the tangent. Since velocity is changing from point to point, motion is an accelerated motion. This motion is an accelerated motion. In uniform circular, remember this, in uniform circular motion, the speed of the body remains constant, remains always constant, but velocity changes from point to point, velocity changes from point to point, because the velocity is directed along the tangent to the circular path, along the tangent, like this. At every point, direction of velocity, here direction of velocity. You know that velocity is a vector quantity. Speed is not a vector quantity, speed is a scalar quantity, but velocity is a vector quantity. It has got a magnitude as well as direction. Since velocity is directed along the tangent, the velocity is changing from point to point. In uniform circular motion, the speed of the body remains always constant, but velocity changes from point to point because the velocity is directed along the tangent. Therefore, uniform circular motion is an accelerated motion. So, uniform circular motion is an accelerated motion, uniform circular motion is an accelerated motion, There is an acceleration in this motion, but this acceleration is such that it changes the direction of velocity only, but cannot change magnitude of velocity only. Since it is an accelerated motion, it has got acceleration. As you know, acceleration is a vector quantity. It has got magnitude, it has got direction. We will find out what is the magnitude of this acceleration, what is the direction of this acceleration. this acceleration in uniform circular motion is such that it can change magnitude, it cannot change magnitude of velocity, but it changes only direction of velocity. This acceleration is such that it can change magnitude of velocity only, it can change, it cannot change magnitude of velocity, but changes direction of velocity only, direction of velocity only. But changes the direction of velocity only. So, in which direction acceleration is there? The acceleration is such that it cannot change the value of velocity, but only changes the direction of velocity. So, your direction of acceleration will be perpendicular to the direction of velocity. So, direction of acceleration will be perpendicular to the direction of velocity, perpendicular to the direction of velocity. Acceleration direction, velocity direction को perpendicular होगी रहिबा circular motion. What is the direction of velocity? The velocity directed along the tangent. Which direction is perpendicular to tangent? The radius is perpendicular to tangent. So, acceleration will be along the radius. The direction of velocity is along the tangent. Direction of velocity is along the tangent and radius is perpendicular to the tangent. Therefore, the acceleration will be along the radius. So, this acceleration is called radial acceleration. So, this acceleration is called radial acceleration. So, the acceleration along the radius, whether the acceleration is directed toward the center or away from the center, because toward the center along the radius, away from the center is also along the radius. So, in which direction it will be there, whether it will be toward the center or away from the center, the body is constrained to move the circular path. So, the acceleration must be toward the center. If it is away from the center, the body cannot move on the circular path. Since the body is constrained to move on the circular path, the acceleration must be toward the center. Since the body is constrained to move on the circular path, the acceleration must be toward the center. So, this acceleration is called central acceleration. This acceleration is called central acceleration. So, now we have discussed that when a body is moving uniformly over a circular path, there is an acceleration of the body. The acceleration is directed toward the center of the circular path. So, this acceleration is called radial acceleration, at the same time it is called central acceleration. So, we have established the direction of central acceleration. In the next class, we will find out expression for central acceleration. What is the magnitude of central acceleration? After we find out the magnitude of central acceleration, we can find out the force. The central acceleration will prove that central acceleration will be v square by r. If mass of the body is m, force acting on the body is mv square by r, and that force will be a centripetal force, that is center seeking force, which acts on the body and directed toward the center of this circular path. Next class we shall discuss that. Thank you.